Welcome, friends. I am Dr. J. Juliet Josephine Joy, Professor of Physics from Hindustan College of Engineering and Technology. In this video, we are going to discuss about hysteresis based on domain theory. First, we have to see what is hysteresis. Hysteresis means lagging behind. When a ferromagnetic material is subjected to cycle of magnetization, intensity of magnetization and magnetic induction lag behind the magnetizing field. If an alternating magnetic field is applied to the material, its magnetization will trace out a loop called a hysteresis loop. When a ferromagnetic material is subjected to an external magnetic field, there is an increase in the value of resultant magnetic moment of the specimen. This is due to first one is the motion of domain walls. Second one is the rotation of domain walls. When a small external field is applied, that is H is applied, the domain walls is displaced slightly in the easy direction of magnetization. This gives rise to small magnetization corresponding to the initial portion of the hysteresis curve, that is OA. Now, if the applied field is removed, then the domain returns to its original position. Therefore, this region is called the reversible wall displacement, or we can tell this domain is called the reversible domain. Then, when the field is increased to a large number of domains contribute to the magnetization, and thus magnetization increases rapidly with H. Now, even when the field is removed, because of the displacement of domain wall to a very large distance, the domain boundaries do not come back to their original position. This process is indicated by AB, and this domain is called the irreversible domain, or we can tell irreversible wall displacement. Then at point B, all the domains have got magnetized along the EC direction. Now, when the field is increased, the domains start rotating along the field direction, and the anisotropic energy is stored in the hard direction, that is represented by BC. Thus, the specimen is said to attain the maximum magnetization. At the position, even the after removal of the external field, the material possesses the maximum magnetization called the residual magnetization, that is called OD. This is called the residual magnetism, or we can tell retentivity. The portion OD is called the retentivity. Actually, after removal of the external field, the specimen will try to attain the original configuration by the movement of the blotch wall. But this movement is stopped due to the presence of impurities, lattice imperfections, etc. Therefore, to overcome this, a large amount of reverse magnetic field is applied to the specimen. The amount of energy spent to reduce the magnetization to zero is called the cohesivity. Therefore, this area OE is called the cohesivity. Then we have to see hysteresis laws. If the loss of energy in taking a ferromagnetic specimen through a complete cycle of magnetization and the area enclosed is called the hysteresis loop. This loop is called the hysteresis loop. Based on the area of the hysteresis loop, the magnetic materials are classified into two. First one is a soft magnetic material, another one is a hard magnetic materials. Then application. Magnetic material having a wider hysteresis loop is used in the devices like magnetic tape, hard disk, credit cards, audio recordings, as its memory is not easily erased. Magnetic materials having a narrow hysteresis loop are used as electromagnets, solenoid, transformers, and relays, which require minimum energy dissipation. Thanks for watching. Thank you.